Okay, so hello everyone. Today we will discuss about uniform circular motion and SHM. So first of all, the circular motion will draw a circle over here. Okay, and this is in the simple harmonic motion we will take the straight line. Okay, so yeah, first of all we will point one, mark a point. For suppose this is point P, and this point P has the projection on this SHM, which is Q, projection, or you can say shadow. Q is basically what? Q is the shadow which is made of the point P. Okay, with that, here I have another point and its shadow is over here. Same, I have another point, its shadow is over here. So here what is happening, I have some points whose shadow is on the simple harmonic motion, which is Q. Okay, so in this diagram the motion of we can say particle P is circular. Okay, the P will move like this. P circle में move करेगा. However, this Q particle will move first there. Then ये क्या करेगा? ये दूसरा ऐसे सर्कल कंप्लीट करेगा. Q का पार्टिकल यहाँ आ जाएगा. So this means ये P क्या करेगा? ये P सर्कल के अंदर घूमेगा. However, ये पार्टिकल जो Q है, जो कि शेडो का है, वो बैक एंड फोर्थ मूव करेगा. ओके, motion of particle P is circular. ठीक है, and the motion of particle P or shadow of Q or shadow of SHM will move in back and forth or vibratory motion. कैसे घूमेगा? Back and forth or vibratory motion. Okay, so now here we have what? Here you can see the maximum point on the line SHM is equal to the diameter. For suppose here in this we have the maximum point, which is, yes, I have, this is the maximum point of SHM and this is the maximum point of SHM. So this maximum point of SHM will be the diameter of a circle. So we will not, we can say, make the shadow on another line to take SHM. We will just put the shadow of SHM on the circle diameter, as the maximum point of SHM on the line are equal to the diameter of a circle. Okay, so we'll make shadow at the we can say circle diameter. So here we will, now let's have a look to SHM. SHM, we will find velocity, we will find displacement, and we will find acceleration of the, we can say, uniform circular motion or SHM shadow. Okay, so let's have a look first to the displacement. Okay, let's have a look to this displacement of what? The displacement of a shadow. For suppose here if I have circle, fine. Here I have this shadow which is SHM, we denote as the diameter of a circle, and point A, point B. With that, here I have point P which is moving in a circle point P. Fine. And the shadow of point P on the diameter is Q. Q is the shadow. So this position will be what? This will be the mean position at which it will start. Mean position, okay? And this is the radius of a circle, and it will make an theta angle between that. So we can say displacement from mean position to, we can say, shadow of, we can say, point will be denoted at x. So we'll find out x. X is basically here the displacement which is from mean position to the shadow, we can say shadow of a SHM. So first of all, write always displacement is measured from mean position. हमेशा displacement कहाँ से measure होगी? Always the displacement will be measured from mean position. Mean position, okay? X here is basically displacement of shadow. Displacement of shadow. Now here we will use, we can say, cos theta, because the base and hypotenuse are given in this equation. As we have learned, which is some people have curly brown hair, throw purple brush. So here we will use cos theta, as cos theta is equal to base upon perpendicular. So here you can see base is given, which is x, perpendicular, which is given r. Okay, so this will be x upon r. Fine. Now here will be r cos theta will be equal to x. So this means we have denoted what is value of x. X is r cos theta. Now we have to find out theta, what actually the value of theta is. So remember we did the formula in the circular motion, which was theta will be equal to omega upon t, with that omega was equal to theta upon t. So theta is omega upon t, we will put the value. X is r cos, at the value of theta we'll put omega upon t, while omega upon t. So now this is the displacement of a shadow. This is the displacement of a shadow. So now let's discuss the minimum displacement and maximum displacement. Maximum displacement. Okay, so in the maximum displacement, if angle is 0, this means x is equal to r cos theta. अगर s पूरा ही बराबर हो जाता है r cos थीटा के, so this means अगर हमारे पास एंगल क्या बनेगा, एंगल पर 0 बनेगा, जो हमारे पास x जो डिस्प्लेसमेंट है ना वो रेडियस के बराबर हो जाए, r cos थीटा के क्या हो जाए, बराबर हो जाए. So this means यहाँ पे हमारे पास एंगल क्या होता है, एंगल होगा 0. And you know that cos 0 क्या होगा, 90, that will be x is equal to r. तो मतलब जो आपके पास x डिस्प्लेसमेंट किसके बराबर हो जाएगी, रेडियस के बराबर हो जाएगी. So here we have the maximum displacement. Remember जब हमारे पास x क्या हो, डिस्प्लेसमेंट पूरी बराबर हो जाए किसके साथ, रेडियस के साथ, एंड एंगल क्या हो, 0 हो, तो it will be the maximum displacement. And you can see the maximum displacement is also known as amplitude. Maximum wait a second. Maximum displacement is known as amplitude. Is known as amplitude. So now let's discuss the minimum displacement. minimum displacement. Minimum displacement is like if the angle is 90, this means कि we can say x and r क्या है? Those are perpendicular to each other. The angle is 90. Okay, and you know that we can say cos 90 is equal to 0. Cos 90 किसके बराबर होती है 0 के. So this means when 0 will be multiplied to whole term, it will be 0. So this means displacement will be 0, and 0 displacement is minimum displacement. So remember, at the mean position, the displacement is 0, and at extreme position, the displacement is maximum. So I hope you have gotten the concept of the displacement in this video, maximum displacement, minimum displacement. In the next video, we will discuss about the velocity. So till that, bye bye.